This video is about average velocity, which is the slope of the secant. And what we're going to do is throw a rock up at 20 meters per second, which will give us this formula. And we're going to move this into instantaneous velocity. But let's take a look at this. If we throw something up at 20 meters per second, that's our formula. So it looks like this. I'm going to hit play. That's our parabola. Let's look at just the height. So if I hit play, it goes up and then comes back down. And so in here, there is a velocity, a speed that it is traveling straight up. Initially, it's at 20, and then it's going to slow down until it hits 0 at its max height. And then it's going to come back down and speed back, right back up to that 20 in a negative form. So the parabola just tells us the height. So here at 0.95 seconds, we know our height would be 14.578, so it translates to there. So as you move through the parabola, it just tells us the height of the object. And if we take any of those heights and subtract them, it tells us how far we've traveled, and it tells us the time it took us to get there. So by dividing height, distance, change in distance over change in time, we get our average velocity. So that's what we're going to do. We're going to plug in 1 for h and plug in 2 for h. And on each of these, it'll tell us the height it was at 1, and then tell us the height it is at 2. And then by subtracting them and dividing them by the time, slope, it'll tell us the velocity, the average velocity that it has traveled over that time. It's like going to Vegas. If you start your car and you drive to Vegas, you have a total distance and you have a total time. So you can get an average velocity for your travel to Vegas. If I plug in 2, same thing. And we plug these in our calculator. And so at 1 second, it's 15.1 meters high. And at 2 seconds, it would be 20.4 meters high. So 15.1, 20.4. So at 1 second, we have 15.1. 2 seconds, 20.4. So that means to go from here to here was 1 second. Right? That took 1 second. And what was the total distance? So our slope of our secant, which is our average velocity, is 20.4 minus 15.1. And we went 2 seconds to 1 second. So what does that give us? So 20.4, I know this is an easy calculation, but we're still going to do it in the calculator just to make sure everything is perfect. 5.3. So 5.3 meters, and that took 1 second. So that is 5.3 meters per second. That is our average velocity. And so here you can see that it is 5.3. This is another graph that I have. So we went from 1 second was 15.1, 2 seconds is 20.4. So again, those translate to the heights over here. And so that was 5.3 meters per second. So now the next one we're going to do is change it to 0.5. 0.5 seconds away. So we're approaching just like we did in the previous problems. Right there. So we're going to go from 1 second to 1.5 seconds, and those are the heights of the object. And so it should be 7.75 is our average velocity. So we already know h of 1 is 15.1 meters. And so now we'll find h of 1.5, same way in our calculator. So it's 20 parenthesis 1.5 minus 4.9 parenthesis 1.5 squared. And that gives us a height of 18.975. Just like in the picture. So now our slope of our secant, which is our average velocity, is 18.975 minus 15.1. That's a change in height over the change in time. So 1.5 minus 1. And so that would become 3.875 over 0.5. And we plug that in our calculator to get 7.75 meters per second. So that is our average velocity along that. And so remember, this is just t equals 1 and t equals 1.5. This is t equals 1 and this is t equals 2. Okay, so all of these has just been the difference quotient. That's all we've been doing. Remember the average velocity, the secant, it is the difference quotient. So if we find the difference quotient here, so h of t plus h, would be 20t plus h minus 4.9t plus h squared. This would become 20t plus 20h minus, I'm going to do this quick, 4.9t squared minus 9.8th minus 4.9h squared. So if you remember, this is just t squared, so 4.9t squared, 2th, so 9.8, and then finally h squared. So we get this. And all we're going to be doing is subtracting our h of t. So we're going to minus that, right? So we write that one, 20t minus 4.9t squared. So these will cancel, giving us h of t plus h minus h of t is 20t minus 9.8th minus 4.9h squared all over h, all over h. So that means our average velocity formula would be, that's an h, that's an h. Should only have h's left there, so 20h. So that would be 20 minus 9.8t minus 4.9h. Now I'm just showing you everything there is for these problems so that you have every single question in one. So now we have the average velocity. So you have some initial t that you want to find the velocity at, and you have the distance from it, and that will tell you the average velocity. So like our first one, we went from 1 to 2. So if we were to plug in the average velocity, right, from 1 to 2, this would be 20 minus 9.8, and we're going from 1, minus 4.9. And remember, h is the distance between the two. So h would be 2 take away 1, which is 1. And if you plug this in, you'll see that it becomes 5.3. So 20 take away 9.8, there it is, 5.3. So it's another way of finding average velocity. If you find the difference quotient, you go from 1 unit away. And so this one here, this would have an h of 1.5 minus 1, which is 0.5. It's just the distance between the two. It's your denominator. That's your h, that's your h, h. You see it? They're the denominators. So it's the distance between them. All right, but all it wanted was the difference quotient. And so there we go. Now we're going to use that to think what would be the instantaneous velocity at t equals 1 second. So if we plug that in, our average velocity at 1 second, right, would be 20 minus 9.8. I know this is not proper notation, but you get the idea. This would become 10.2 minus 4.9h. And so think about your h. H is the distance between the two. So we already did a little bit. We saw that our average velocity was 5.3 from these two, and then we cut it to half, right, to 0.5. There we go. And at 0.5, it was 7.75. So you can see they're approaching something, right? It was 5.3, and it's getting bigger. The average velocity is increasing here. And so as we get closer, or as our h approaches what number? Our h is a distance between them. It's approaching 0. So as our h approaches nothing, it's going to give us our average velocity. Remember, they're increasing. So you can see it's approaching some number, and we have it right here. So if you want to quickly find it, you just say h approaches 0, and so your instantaneous velocity at t equals 1 second would be 10.2 meters per second. So the difference quotient not only gives us all the average velocities, it also gives us our instantaneous velocity for our parabolas and our polynomials. A little bit tricks on the other ones. Okay. You can also use it for our table. So we've already done a little bit of this. At 2, we got 20.4. So we're just going to put it all together now, 20.4. At 1.5, it was 18.975. And you already know how to find these points. You're just going to plug them in. And so we're going to use the calculator to find them. And by calculator, I mean Desmos. So at 1.1, it's 16.071. And then we just slide it back to 0.0001. See, all the way to the back. And we get 15.11. Remember, the h is the difference, so we're going from 1 to that number. So from 1 to 2 is a difference of 1. And so all we're really doing is just subtracting. So we're just putting in that h, which is that distance. And then we do our subtraction. So 20.4, and we knew at 1, it is 15.1. Right, so it's 24.4 minus 15.1. This is the same stuff we did earlier, just putting it all in a table, minus 18.975, and then we divide it by 0.5, and then this one's backwards. 18.975 minus 15.1 over 0.5, and then 16.071 minus 15.1 over 0.1, and then 15.11 minus 15.1 over 0.001, and that gives us the slopes of our secants. And now you can even use our formula here. This is just 10.2 minus 4.9 h. So what is 10.2 minus 4.9 times 1? That's 5.3. And then if we minus 0.5, we already knew that one was 7.75, but you don't actually have to calculate this. You can just use the difference quotient. So this is 10.2 minus 4.9 times 1. This is 10.2 minus 4.9 times 0.5. They are the same. This is 10.2 minus 4.9 times 0.1. And this is 10.2 minus 4.9 times 0.001. And either way, when you plug them in your calculator, you get this value. So 10.1951. Make sure that one's correct. 10.1951. Yep. But if you just plug that one in your calculator or that one, you'll see they're exactly the same. So 10.2 minus 4.9 times 0.1. So there are a lot of ways to do this. 9.71. So you can see they're approaching. So as our h gets closer and closer to 0, what we end up with is a tangent line. And so that is the slope of the tangent that we want, and that is our instantaneous velocity. So the slope of the tangent is the instantaneous velocity. Which is basically the velocity at 1 second, which we found is 10.2 meters per second. And there you go.